Okay, optional question. And, it's about integration, how confusing it can be at times. But you're going to learn more about integration in Math 122. Right now, I think you probably should have a good idea of how to do a U substitution, and you should have a pretty good list of known antiderivatives. Now, looking at this problem over here, I would not consider this to be a known or general antiderivative that you should know. However, it is a known antiderivative. All right. So what I'm going to claim over here is if you were given this thing over here, and you're asked to do that, and let me what I mean by that, asked to do a definite integral between -1 and 1, and you have the root of 1 minus x squared dx. I would like to visualize it first. And if you visualize this thing, well, if you did the integrand would look like a semicircle, and that's between -1 and 1, and you're looking at this area over here. And what would that area be? Well, let's see. You would get, that's half of a circle, right? A unit circle. And a unit circle's area is pi, and since it's half of it, you would get pi over 2. And I would call it a done deal. And that's visually doing it. And that's the way we did it prior. All right, now if you were to use the known antiderivative to do that, you would expect to get pi over 2 as well. So let's take a look at that. And I'll write this one down. I'm going to do the evaluation over here. The upper limit is 1. Let's plug that in. You're going to get 0 plus the arc sine of 1, which is pi over 2. This is over 2, minus, well, let's see, lower limit's -1. Well, the root's going to still evaluate the 0. And the arc sine of -1 is minus pi over 2. And if I did this, I'd get pi over 4 minus a minus pi over 4, which is plus pi over 4, which of course is pi over 2. As expected, by the way. We're expecting that. All right? So I'm going to say, we visualized it. Let's say you knew the antiderivative. You could do that. You get the same area. No confusion there. All right? So what happens now? What happens is, if someone said do U substitution on the problem, you might be confused. All right? Now, certainly, if you're unwilling to think about why you're confused, that's a problem. Now, certainly, I'm of the opinion, too, I hate to admit it, I had to think about this. I said, what just happened? So let's go through it, all right? And this is, they're asking you to do U substitution now. And the only U substitution I could think of that might possibly work out is to let U equal this thing over here. And if you did that, let me write that down for you. If U equals 1 minus x squared, typically you change the limits of integration. And what's surprising here is that -1, it evaluates U to 0. And at 1, it also evaluates to 0. Now there's something over here, and then there's going to be a du. And someone says, does it really matter what goes over here? Well, if that's my limits, and this is a nice looking integrand, I would say no, not really. It has to be 0, all right? Because it just shrank to 0. Now, this is unfortunate, by the way, and I'll tell you why it's unfortunate. What happened was in any integration, if you have an integration like this over here, and you're looking for the area, maybe something like this over here, and you're going between this, and the area here, and let's say this is A and B, and you did a substitution, and it shrank to 0 because the roots are 0. Well, looking at the integration, it does appear to sum to 0 if these areas are identical, right? But what if you had this over here, right? You had an integration that looks something like this over here, and you were looking at this guy over here, and this was the limits of integration. Well, if you made the substitution over here, these are both going to evaluate to 0, all right? So that's where the problem lies. So let's take a look and see what's happening over here. So I'm going to erase this business over here, and I've got a problem now, all right? And the problem is I really have to start thinking about the substitution, all right? So let's take a look at it, all right? So let's take a look at the substitution more carefully, and we'll write it down. So remember, we said U is equal to 1 minus x squared, and then du would be minus 2x dx. I want to point out, I do want to solve for x. So what would you get? You would get x squared is equal to 1 minus u, or x would equal, and this is a problem, by the way, plus or minus the root of 1 minus u. Let me go back over here and point out this stuff is being written down for you for a reason, by the way. We got it all written down. Now, the problem, again, is we have our limits both evaluating to 0. So it appears like it shrank to nothing, but it didn't. So what we have to do is we have to split the integral along the path between -1 and 1. And I'm going to say a good place to do that is at 0. So you start at -1, go to 0, start back up at 0, and go to 1. So I just put it into two different problems. And now what I'm going to do, the substitution. All right? So let's just do, -1 first. And -1, in the land of x's, would evaluate to 0 in the land of u's. And the 0 would evaluate to 1. All right, let's do the other one. I split it. At 0, it's going to evaluate to 1, and at 1, it's going to evaluate to 0. Okay? And we're going to plug in now. All right, what are we going to plug in first? We'll plug in this. And what's that going to be? Root of u. I notice there's an error in my notes, but I will correct it. And then what do you get on bottom? And this is the tough part. I have to think. All right? I have to think. Let me get my eraser out. Erase this business over here. I'm going to point out what the errors are in the notes too, but I will correct that. You're not going to see that in the notes, by the way. The reason I've seen them because I'm going back over it. So these things over here, whoops, let me just highlight it for you. These things should actually be used in the problem. They're going to be changed. You're not going to see that. I'm seeing that. A little disturbing at this point. All right, so let's take a look. All right, and this really requires some thinking over here. So let's just do one integration at a time. I'll do this one first. All right, so let's write that down. So it's going to be -1 to 0. You would get root u, and now I got to put the dx down. And what's the dx going to be? Let's think about it. Well, the dx is going to be du over -2x. I'm getting that from this over here. But then I got to think about what the x is on that interval between -1 and 0. It's negative, right? So what I have to choose then? I've got to choose the negative part of this. So let's write that down. Du would be -2 times minus, or the opposite of the root of 1 minus u. All right, what does that give me? That would give me, as expected, this one over here. All right, so we got that integration done. Maybe I shouldn't say it's done. We got that integration written down. Let me do the other one. Let me erase this one over here. We finished that. And let's start the other one now. All right. Again, I'm going to highlight this has to be written as a u. That's going to be written as a u, and that'll be corrected. Let's do this integration here, and let's write it down. What do we see? Well, we got the limits, 1 to 0. We did that before. I have the root of u. And remember, what's the dx? The dx is going to be du over -2x. Well, between 0 and 1, what do I get? I get, let's write that down, dx du. When the x is positive, what do I get? -2 times, I'm looking at this, the root of 1 minus u. All right, let's see if that's written down. We got the root u -2, that. All right, so I think I'm pretty good with that. I got that part covered. All right, and let me keep moving forward. Let me erase this business over here. And let's go to the next step. And these integrals both look very similar to me. All right, so what I'm going to do is work on the second integral. And I want to rewrite it. The second integral, I'm going to rewrite that. All right, and put that down for you. What do you go there? You would get minus, that would be root u. And this would be 1 to 0. And you would get 2. I just factored -1 out, by the way. This over here. Well, I'm going to write it a little differently. It's the opposite, so it's going to just be this over here. Plus 0 to 1 root u over 2, 1 minus u du. All right? So let's show you where that is. That's written right over here. 0 to 1. We got this over here. These things are bothering me. I'm going to write them down. They're u, 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 u. All right, looking at those two integrals now, they both have the same integrand, and they both have the same limit, so there's 2 of them. All right, so if you wrote that down, there would be 2, and they're identical integrals, by the way. Root u, 2 root 1 minus u du, which gives us a pretty simple integral, by the way. 0 to 1, root u. Okay, this is our final integration. I got to be honest with you, this is a tough integral. At least in my opinion, it's tough. So I'm going to say there's a couple of reasons why it's tough. One is at the limit of integration, the bottom is shooting off to infinity. It's improper. Now you're going to see this in more detail when you take Calc 2. But however, this integration here still evaluates that number over there, as expected, we wanted to. Now, by the way, I put a graph down for you. It's figure 179 on page 517. It's a visual. Yeah, let's take a look at it. And what do we have? The green area, that's the semicircle. That area is pi over 2. And then we got this, reddish area over here. And this also is, although improper, it's that integration 0 to 1 root u over the root of 1 minus 2 du. It still integrates to pi over 2. And granted, if I were doing this problem, I would not do u substitution on it. However, I want to point out again, you might be horribly confused sometimes. By the way, sometimes also right, not confused. Like if you did this, a lot of integrals, this does happen, and it is in fact 0, but not in this one. I would say try to visualize the problem before you make some hard conclusion about what the value is. How do you visualize? If it's difficult, use a computer. If it's easy, and this is an easy visualization, by the way, it's easy to determine that's a semicircle. Definitely visualize, right? If it's more difficult, you might have to go to a computer to visualize it, though. It's important you start to visualize things, though. Thank you.